So we'll be back. Give me 1 second here while I pull everything up and see where we're going, because we're getting close to the end. By the way, I should have your discussions graded by tomorrow. Remember, you got one more discussion coming and then you're done for after that. All right, so notice, I'm gonna get emails over this. I moved your 10-2 to this week. So you got 10-2, 10-3, 10-4. I don't know if you noticed it, but you do not have a chapter 8-10 test anymore. I just got rid of it, okay? We're too close, we're right here toward the end, so I just said, let's just get rid of that chapter test. Let's just focus on you getting your project done, a little paper, okay? And then worrying about just everything else moving forward. Okay, so let's kind of look at that real fast. Notice, like I said, 10-2, 10-4 is due to the 27th. 10-5, now I want you to be very aware of what the 4th is. That is the day before finals week. Okay? Everything shuts down at midnight. If you are working on homework on the 4th, it will turn off on you at 11:59. Okay? And you will not be able to access Hawks anymore after that, okay? So kind of, there's the warning right there. I will not accept that critical thinking after that day as well. Matter of fact, I want you to be warned, I'm changing the time on it for that day. Okay, it's not gonna be midnight, it's gonna be like in the afternoon, probably like around 2 o'clock. Okay, just a warning right now. At 2:05, I will not accept it. Don't email it to me. I will not accept that critical thinking project. Okay? So get it, if you want to, get it done before then. Okay? I'll have a way for you to turn it in. Okay? Reason being is after 2 o'clock, I'm preparing for y'all's finals. Trying to make sure everything's ready for that, make sure the Hawks is working right. That's my focus at that point. Okay? Good? Okay. Just want everybody to kind of know what's happening. Okay? So, like I said, that critical thinking was due on the 30th. I gave you an extra 4 days on it. 3.5. Okay, to kind of help you out a little bit. Okay? Don't squander the help. Any questions over what's coming? And then I am showing right here, supposedly that you have your final, this class, okay, from 8:30 to 10:15 on Monday. For those in Zoom, I don't know how it works over there, but I will be sending your proctors out the password to get in so y'all can do it with them. Let us double check the calendar very quickly. It's always a good idea to always double check. In woodwork, they say measure twice, cut once. Come down here. We are Tuesday, Thursday, 8:30. Yes, there we are. 8:30 to 10:15 on Monday. That is your final schedule. So if you need to take a picture of that so you have your final schedule, you can. Remember, all your schedule will change. This final schedule is the 5th to the 7th. Okay? If for some reason you think you're going to be absent, don't worry. I have a way for you to take it at home. You're not going to like it, but I have my ways. Okay? Good? Anybody taking a night class at all? Okay. Because there is a night schedule down below. Okay. Good, everybody got it? Okay. There we go. Let's jump back in like very, very quickly. I want to kind of go back over because of all the difficulties we've had on with technology and everything else. I kind of want to go back to this part really quick here. At the end here. Notice here, right here, when we're drawing a conclusion, okay, don't get hung up. First off, throw out a hypothesis. The null hypothesis is assumed to be true. That is context. Okay, right now for you, that's just context. So don't get hung up on that word. Also, don't get hung up on the fact that no matter what the conclusion of a hypothesis test is, neither the hypothesis has been proven to be true. neither hypothesis is proven true. You need to focus on what that conclusions of the hypothesis test, okay? Where you reject the null hypothesis or fail to reject, okay? Rejecting the null hypothesis is this, okay? You're saying this. When you start looking at the numbers, and it's going to become more clear in 10-2 as I start working this out for you, you're going to go, okay, even if you don't understand it perfectly, the math behind it, you can just go, don't quite get it, but guess what? Here we go. I'm going to go with what the math says, okay? But rejecting the null hypothesis says that when you do your little hypothesis testing, is you're saying there is sufficient evidence to say there's not enough information, there's not enough evidence to say that the null hypothesis is, hear my words, true. Remember, we don't really base it off true, okay? So you're basically saying this, there's not a great probability that the null is true, that the common belief is true. Failing to reject is just a fancy way of saying, I've proven the null wrong. You've proven nothing, but I'm saying the word proven to help you with the vocabulary. You've actually proven nothing. There's just a low statistical, you just said, hey, I think I'm right, and the probability is on my side, right? Okay, that's kind of what you're saying. It doesn't mean you're right, because what's going to happen is later on, somebody else could do a study and they go, hey, you know, some new data's come out, and guess what? There you go. That kind of help you out a little bit, understanding that reject and then fail to reject. Okay. And then, of course, in 10-1, we went through and started kind of going to look through some of these and deciding what we should do, like this one right here, the campaign manager one. Good news is on a lot of this, on a lot of your final, you don't have to go in there and put the hypothesis. I'm going to give it to you. Okay. You just got to remember, is this going to be equal to, not equal to, sorry, not equal to. You're not equal to, less than, or greater than. Okay. Because remember on this one right here, we did this one in class. First off, look at it carefully and realize that, hey, there's a percent symbol there. So that means I'm not using a mu. I'm going to be using a p. Okay. And then we have two things. We have the null, and then we have the alternative. Now, if you take another statistics class, these are not dedicated little subscripts. They are sometimes changed. Okay. For this textbook, they use H sub 0 and H sub alpha. Other textbooks use different ones. I've seen H sub 1, H sub 2. Okay. So don't get hung up on that if you see it later on. Just focus on the H. Okay. Or our null is always an equality statement. Always. Okay. You need to know that because it has to be an equality. If it was not an equality, that means you're trying to prove something for them. Okay. So we just make it an equality statement. Okay. And then we keep looking at this and going, look, historically, that sounds like a common belief. Okay. Of 0.25. Good news. Everything matches right here. Always. That will always match. Okay. If you're dealing with a proportion in the null, you're going to be dealing with a proportion in the alternative. If you're dealing with this percent on top, you're going to be dealing with this percent on bottom. Okay. You can't test something different than what you're comparing to. That wouldn't make sense. That'd be like me saying, hey, I'm going to see if there's a big study that came out right now that says if you take 10 grams of creatine a day, it helps your brain. Well, I'm not going to go, I'm going to take 10 grams of creatine a day. That's the common belief. I'm going to test that out with Kool-Aid. That makes no sense. I've got to test creatine to creatine. Okay, so that's kind of what you got to think of. But here I've got to say, is it going to be greater than, less than, or not equal to? So notice you can go here and it says a larger vote, so I would put that there. Now, the result is to reject the null hypothesis. Okay, that's on 10-1, it gets a little bit murky. In 10-2, You want a little hint? Get through 10-1 quick. Okay, learn how to do the null and learn how to do the alternative. Because you know what's easier in 10-2 through 10-5? I'm going to give you math. And the reason the math, you're going to like it, is even if you're not understanding when to reject or when to fail, the math is going to tell you when to do it. It's going to say, because this number is greater than this number, this is what you do. If this number is less than this number, this is what you do. And then you just go along with it. Okay? So are we good so far? Can you find hypotheses? Can you see the common? Can you see the other? So can you see the alternative? Oh, sorry. What should you be looking for? Because we are literally, as of almost, well, we're less than 2 weeks away from your final, 13 days to be exact. You need to start looking at, like, how do I know? Like right now is the day. This is how come if you go look on your Canvas shell, there's a review there for you. Now, if you were in my intermediate class, or if you were in my college algebra class, they're lucky enough, they have a filled-in review that they can go look at the math. You do not have that. There's a reason for that. Okay, there's a method to my madness. Is one, you're more mature math students. You should be willing to do some legwork. But two, I want you to be able to go, okay, here's my question on my review. Start jogging through your memory and go, where did I learn that? Did I learn that in chapter 6, 7, 8, right? And then go, okay, I think I learned, obviously it's probably, let's say 8-1. I think this is 8-1 because look, it's talking about intervals. We learned about intervals, okay? Population, hey, there's a population here, a population standard deviation. I've got to go find the question in 8-1. I'm going to look it up in my Hawks, go find that question, and I'm going to learn how to work this question right here. That's what's going to happen on your final, is everything's jumbled. I don't do everything in order, okay? You may get a question from chapter 12 as your question 1, okay? And then chapter 8 for question 2, chapter 7 for question 3, okay? Don't think there's a bunch of chapter 7, just FYI, okay? But you need to be able to like kind of think in your head, where am I going? Because think about it, we got a bunch of tests we got to look at. You got different intervals, you got a Z, you got T-scores, you got that chi-square, whole bunch of things your brain's got to kind of jump through. So I kind of want to help you all out with that, okay? So we've done 10-1. We're good so far. Let's jump into 10-2. Any questions over 10-1? Are we good? Were y'all okay with it doesn't come back? Were y'all okay with the types of errors? Were y'all okay with that? Into. Go through this one. I'm gonna kind of start from the beginning again and then get through this one, because this one we got cut off. Okay, so y'all kind of got a whole lesson, but they got kind of cheated online as well. But let's go ahead and look through this one. 10-2. Okay. Should make you think what? 8-1. Because what did we learn in 8-1? Sigma's known. Sigma is population standard deviation. Now, when you start looking at some of the questions for this one, you're going to notice that they don't say the words intervals, confidence intervals, okay? In fact, a good little hint is even on those kind of questions, you're going to see right there at the very bottom of the first question, it's going to say, hey, what's that? That looks like a mean is equal to something. And you're going to have to decide, are you going to use sigma known or sigma unknown? Now, sigma unknown, because I do want to kind of always keep us reviewing, well, if I was using sigma known, what type of critical score am I going to use? Think about it.
Z.
Z, exactly. It's a Z score. But not that Z scored very good. You were guessing, weren't you? She's like, I got 2. I'm going to go 50-50 on this. A Z. Well, because remember, in chapter 8, we had that little interim chapter of 8.2 that you learned about that student's T distribution. Then we have to use, when we don't know sigma, we use the T. Same thing. Good news is, in chapter 10, everything can be done on a calculator. Bad news, your project, use your calculator all you want. I want to see math and I want to see drawings. Okay? If you want to know the level of detail I want, go look at the work shown. Okay, that's on that page. Anything less than that will just be counted wrong. Okay? For step one, state the null and alternative. That's what you did in 10-1. You look at it, you read the question and go, what's the common belief? What is the belief that they're telling me? And then what's the alternative? Okay? Now, got to check the conditions are met. Okay? Once again, because of the central limit theorem that we kind of stand on, we still have to say, hey, one of two things has to happen here. Either I took plenty of samples or the distribution is roughly normal, but also, for our purposes right now, sigma is known, which means you're probably going to read somewhere in that question a whole bunch of stuff, but then somewhere they're going to say a specific word. The population standard deviation is, and that's when you go, all right, this is 10-1. This is what calculator button I'm using. Or this is what critical value I've got to look up in my book or the table I'm going to give you. Okay? Either way, you got to do something like that. Formula for testing. Here it is. Now you may say to yourself, why do I need that? I'm going to use my calculator. Because you're going to need it for your project. Okay, that paper. Okay, so this is really important right here. You did it before. You did it in A1. You didn't do it in A1. You looked at it in A1 and used your calculator the whole time because you use that Z interval. Okay, but it is the same thing. You did it in 7-1. 7-2 actually, I think. Okay, so this one has been just kind of carrying its way through. Okay, very simple. Notice we have X bar, that's a sample mean. We have the mu, which is the population mean. They're using that sigma term because the population is given to you. That population standard deviation is given. Okay, and then you have the number of samples. Take the square root of that. Very simple. Okay. Next step, you would gather data. Good news, you don't got to. Hobbs is going to ask you questions. They've already gathered the data. They're going to be presenting it to you, okay? And then step 4. Now, draw a conclusion, interpret the decision. Are you going to reject the null hypothesis or are you going to fail to reject the null hypothesis? That's important. Good news is you don't have to kind of, it's not as murky as it was in 10-1. In this one, it's going to be literally a number. You're either going to look at a number or a drawing, okay? Good news is your calculator does either one for you, okay? Not the drawing. It doesn't do the drawing as well, so be very careful. It will help you, okay? I'm going to be honest. It will help you, like, because you're going to need to know tails, which I think we talked about last class. We talked about the tails, okay? Good, then this should be sort of review. And then we have this right here. Very important. You need to know this. Okay, especially once again for the paper you're going to be turning into me. Left tail test, I always say, look at which direction the alligator butt's pointing. And of course, this one doesn't point any direction. So notice this is a left tail test, and it would look something like this if you sketch it out. This would be a right tail test, and it looks something like this. And this right here is a two tail test, and it looks something like this. Now, what you need to know is those colored in red areas. I'm just going to draw it on one. This right here is called our rejection region. Okay. Anything outside of that, anywhere else, this is where we fail to reject the null. And this is your method 1. You would look at your question and you say, okay, the mu is equal to 10. And then you would say, but the alternative hypothesis would be the mu is less than 10. Okay? You look at your question, they give you a bunch of information, and then you're going to find out that z-score. Well, remember what a z-score does? It's just going to tell you the distance from the mean in either direction, right? So if your z-score lands in the red zone, reject it. That's it. You just reject it. You go, nope, there is a high probability that we've found sufficient evidence or whatever it says to reject the null. Okay? Well, good news is there's a little chart here going to tell you in just a second, depending on the level of significance, it'll tell you, can we all agree that there's a specific z-score right there, right? Right there where the rejection region starts, there's a z-score. Well, all you're looking for is, does that thing equal that or cross into it? If it does, reject. Okay, that's when you're doing the drawing, which we're going to do both because you need both. For your final, you're going to love your calculator. I don't need to see any drawing. For your project, got to see a drawing. I don't care if you give me everything right. If I don't see drawings, I don't see graphs, I don't see what I asked for. X, X, X. Okay? So learn both. They're very simple. Okay? Next. You're going to need this. Okay? You're going to be giving it to you. It's also in your book. But notice what it says. If I said, hey, there's a level of significance. Okay? And then I said to you, it's less than. Well, I know less than is negative, right? Okay? Let me put it this way. Let's try it. Very simple. If I said the level of significance is 0.10, here he is right here. We're going to go down that line. Here he is. It is a one-tailed test, okay? And since we are going to say the mu is equal to 10, we'll say the mu is less than 10, we know that's a left-tailed test. I know my arbitrary graph looks like this, right? We also know that normal curves are what? They're equal. They are what? Starts with the S. Symmetrical. So notice it gives me a z-score right here of plus or minus 1.645. That means this z-score where my rejection region starts would be at negative 1.645. Now let's say we do our math. You get all your data and you find a z-score for it. And you say, hey, after I put in my mean and I get my sample mean, I subtract it from the mean and I divide that by all the stuff on the bottom, and I get a z-score of like, say, negative 2. Well, can we all agree that negative 2 would sit inside there? You would reject. But if I got anything less than negative 1.645, it would sit in this area and I would fail to reject. And that's how the drawing works. Now you might be asking yourself, well, what if, let's change that to a greater than symbol. Well, wouldn't that be a what? That would be a right-tailed test, which would look like this. But that's why they give you that plus or minus. That means this z-score on this side will be 1.645. And then notice once again, if my z-score that I calculate falls into that rejection region, you do the same thing, reject it. If it lands in the non-colored area, then you fail to reject. Good so far? We're going to do one, so don't worry about it. Just kind of help you out how to read this graph, okay? Or read the chart. To be honest, you're going to love p-values. That's the next thing. Method 2, p-values. P-values, basically I'm saying right now, calculator, okay? P-value is the probability of obtaining a sample statistic that is extreme or more extreme than the one observed in the data when the null hypothesis is assumed to be true. Now, look at this bottom part here. It says if the p-value is less than or equal to the alpha. Alpha is the shaded area that I just did, okay? Then reject the null hypothesis. If the p-value is greater than alpha, then we fail to reject. Okay? Your calculator is going to do everything for you. Okay? Are you good with that? That's going to be the same way in 10.2, 10.3, 10.4, and 10.5. So you need to remember that. Okay? Because I don't give that to you on your final. You just gotta know it, whatever, okay? And if someone will remind me, I will bring you your note cards next class. Did y'all get them? There you go. And I don't want you to have any more. If you didn't get a note card from me, come to my office after class, and I'll give you. And I'll keep your work in that day. Good so far on that? Okay. Now this one right here, they're just saying basically, hey, give me the null and give me the alternative, okay? And the reason I'm showing you this one is while you did this in 10.1, okay, it tells you the importance of it for one thing. But two, I want you to start seeing, is this going to be a left tail test or a right tail test? Now, Hawks doesn't ask you this, I'm asking you this, okay? So, spoiler alert, we're in 10.1. So guess what? I can tell you right now, if you're in 10.1, you're automatically going to be dealing with mean in both of them. So there you go. But what do you automatically should just muscle memory tell you to put in the first one? The mean is going to be what? Equals. You may not know the number yet, but you can come right in there and just do that. Because the null has to be an equality statement. Okay? But it's equal to what?
401.
401. And then we look at it and then we can continue on. Now, it is believed that the machine is what? Underfilling. So what would that be?
Less than.
Less than. And then we always put what next? 401. Exactly. So what kind of test are we going to have? Left, right, or two-tailed? Left. So this is going to be left-tailed test. For two reasons. One, whenever you start to draw this, you need to know, or your calculator work even is going to ask you, are you putting in less than, greater than, or not equal to? Okay. Now let's do one that you're going to see on your final. We're going to work our way through it. Now, when I get to step 2 of 3, I'm going to do a lot of stuff in 2 of 3 that you don't have, you're going to need to do on your project. You wouldn't do on your test. Gotta be kind of careful. I'll show you what you're going to kind of need. So notice once again, this is actually how you're going to see it on your final. I pretty much give you everything. I already give you the mean, so that's going to help you out. You're going to be like, okay, if he's giving me mean, well, let's just be honest. If I'm giving you something in this format, your brain should automatically go, well, in chapter 10 somewhere. Okay, because you didn't learn about this stuff in chapter 8. So I'm in chapter 10. Okay, we're dealing with mean. What kind of mean am I dealing with? Am I dealing with sigma known or sigma unknown? Obviously, right now, it's sigma known, right? But I'm not going to tell you when you're fine. You got to decide, is there something in here that's going to tell you I'm dealing with sigma known? Well, let's read it. A National Business Machine reports that the mean average age of retirement for women executives is 63.2. A women's rights organization believes that this value does not accurately depict the current trend in retirement. To test this, the group pulled a simple random sample of 78 recently retired women executives and found they had a mean age of retirement of 64.2, assuming, and here is your word, the population standard deviation is 4.4 years. Immediately your brain should go, the population standard deviation is known. Sigma is known. I'm back in 10.2 right now. Okay. Is there sufficient evidence to support the organization's belief at the 0.02 level of significance? That's that alpha, that little, okay, weird little Greek. Step 1, state the null and alternative process for the test. Well, if the mean is equal to 63.2, what are we looking at? Greater than, less than, or not equal to? And it does matter because your calculator is going to give you different values depending. Very good. Not equal to. Awesome job. What made you decide that?
They're not saying greater than or less than.
Yeah. There's no word that says greater than, less than, or some sort of word that kind of says that. Okay. Now, mind you, they may even say the word greater than, but then immediately they may go, this isn't, they don't believe it's greater than or less than. They may kind of contradict themselves. Okay. So that's how we're kind of saying, if it doesn't explicitly state it in some roundabout way, it's not equal to. So you're right. We're going to come in here. We would put not equal to. Put that there. Now, asking for your drawing, would this be a right-tailed, left-tailed, or two-tailed? Two-tailed test, okay? So you need to know that. This would be a two-tailed test. And why does that matter? Well, let's get to some math. Let's get some math and some drawing. Okay. I'm going to do this two different ways for you. One, compute the value of the test statistic. So for those of you who are wondering about that question on your project that says, what is a test statistic? This is the test statistic right here. Okay, first way to do it is this. One, we have a formula. Okay, we have Z is equal to X bar minus the mu, all divided by standard deviation. Then you got to start parsing out some information, don't you? Start filling that in. So do they give us a sample mean? Well, we scan. Yes, they do. They give us a sample mean of what? 64.2. Okay, well, that's important. Let's put that in, 64.2. Well, do they give us a mean of 63.2? Do they give us a standard deviation? Yes, they do, of 4.4. Notation matters. Notice I'm using sigma. Okay, because I know the population standard deviation is known. Then what? Did they give me an n? Little n is always what? Little n. Sample what? Yeah, this number of samples, right? What number would that be?
78.
Very good, 78. Let's put everything into our formula and figure out what that z-score is. Okay, so we're gonna come in here and we've got 64.2 minus 63.2. Four, and then 78. Start working on your calculator, working out on mine. Rounding it to 2 decimal places, right? Okay. So on your calculator, you would look at the 3rd decimal place and know what you're going to go up to the 100th place. Did you get? And if you haven't got there yet, finish it up. Even if I'm going to give you the answer, see if you get the same thing. 2.01. If you didn't get that, try doing this when you're doing it on your calculator. Throw everything in a parenthesis here. Throw everything in a parenthesis there when you're doing all the math. So sometimes, or do it separately. Okay. Top number is easy. It goes to a 1. Okay. We're good there. That is your test statistic. Okay. That's what you would answer for number 2. There's your test statistic. But you know what? As of this moment right now, you know whether to reject or not. Okay, so let me show you. I'm going to show you how to draw this now. Is this a left-tailed or two-tailed test?
So,
Two-tailed test. What tells you it's a two-tailed test? Not equal to tells you it's a two-tailed test. So I have an arbitrary. Right? Looks like that. Notice they give me a level of significance of 0.02. Now, you do not have it. I'm going to scroll back. But if I go look, if you have your book, you could also look this up. If you look at your critical Z values, look at that right there. Erase this so it isn't so messy now. Look at where they have the 0.02. And are we using a one-tailed or two-tailed?
yeah.
Two-tailed. So look at that right there. That has plus or minus 1.96, right? At two-tailed. Oops, I'm sorry, 2.33, wrong one. I tell myself, wear your glasses, dummy. See, glasses. Irony is, I wear my glasses, I can see this, can't see y'all. So, Milwaukee saying, get bifocal, because I'm like, I'm not that old yet. There's not enough gray yet to get bifocal. Huh? Don't do this. So look at this, 2.33. What is that saying? Look at my little test here. That is saying right here, the Z-score right here, it's giving it to me. It's saying, hey, the Z-score you got right here is going to be negative 2.33. This Z-score here is 2.33. We know that because of what side it sits on from the mean, right? What is my Z-score? 3.01. Don't forget Z-scores. Y'all learned this back in the day. I said to you then, I go, hey, Z-scores are going to become very important. Remember that. And y'all went, okay, professor. They're back. Look, can we all agree that 2.01, I'm going to get it way off. 2.01 is sitting right there. Well, where is that sitting? So outside the rejection zone. So we are in the fail to the reject the null hypothesis area. Okay, that's what that's saying. Since my score here, that 2.01, it did not fall into the red zone. I failed to reject. There is not enough evidence to reject the null. Didn't find it. There was not enough. Okay, so there's a high probability, okay, that the null is proved. I'm always going to say that because you really proved nothing. Okay, it's all probability. Okay, that makes sense how I did the drawing. That kind of demystify a little bit. Want to make it easier? You have to calculator and go to stat. Go to test. Go test, right? And then go to Z test. It should be number 1 on your calculator. Make sure that you highlight on the input, highlight stats, okay? And then you're going to have some information put down. You need to put in the mean, okay? So we're going to put the mean, it looks like this, mean is going to be the 63.2. The next thing it asks for the standard deviation, which for us is going to be the 4.4. Then it asks for the sample mean of, what was that one? The 64.2. It asks for N, and that's going to be our 78. And then it says, hey, is it less than, greater than, or not equal to? You put in, not equal to. Not knowing exactly what your calculator does, okay, and I don't want to tell you what mine does, whatever. So we're going to come in here and let me put in my calculator, 60.2, 4, 2, and we are not equal to, correct? Notice, I don't know what your calculator gives you, but do you see a Z-score there on yours? It should say Z is equal to 2.00. But that rounds up to what? 2.0. There's a more important number there. First off, you need that 2.01 because that's going to be your answer for question 2. But look right beneath it. What do you see? Look at that P value. Well, that P, rounding it to 2 decimal places, P is equal to 0.04. Well, let's remember this. When P, okay, well, first off, look at our level of significance. That is 0.02. What number is greater? .04. When P is greater than alpha, well, what do? We fail to reject. Okay? Is that not what you read right there? If P is greater than alpha, then you fail to reject the null. Okay? So notice that was easy. Instead of having to draw everything, you just find that p-value on your calculator using that z-test. First off, that little z-test gives you your critical value, your test statistic. And then right beneath it, you go, and there's my p-value. Well, where did I get that 0.02? Right there. That is your alpha. That's that level of significance. And you're just saying, is it greater than or less than that number? That's it. Being very careful, because not just greater than or less than, look what it says. If it's less than or equal to alpha, okay? Because if you just did greater than or less than, you're leaving out a whole number. Okay, so. How do you feel about that one? It's not too bad now, is it? That's a little bit less murky than it was in 10.1, okay? But now you got to go to part 3, okay, in this question. Well, we do know this. I'm going to help you kind of get this down to at least a coin flip. Okay, everybody remember what that probability is? What's the probability of a coin flip? 50-50. Let's get it down to a 50-50. We know we are doing what? Are rejecting the null hypothesis, or did we fail to reject? We failed to reject. So can we all agree that this question makes no sense here, and this question right there makes no sense? So now you're at a 50-50 point. Okay? Let's look at it carefully. We know we're failing to reject, okay? So we failed to reject the null hypothesis and conclude there is insufficient evidence at the 0.02 level of significance to support the belief that the mean age of retirement for women executives is not 63.2. Or we fail to reject the null hypothesis and conclude there's sufficient evidence at the 0.02 level of significance to support the belief that the mean age of retirement for women executives is not 63.2. Which one do you think? Is there insufficient or sufficient? Oh, wait. Say?
Insufficient.
It's sufficient. Why do you think there's insufficient?
Because you felt to reject the.
Yeah, you failed to reject it, okay? You failed to reject it. So no, since you failed to reject, you did not produce enough evidence, probabilities, enough evidence to conclude that that was true. Once again, I will say the true statement, okay? So that's how come. So when you fail to reject, it's always going to be insufficient. So there you go. Let's do another one. You can't do too many, especially with finals only 13 days away. We still get through chapter 12. Just 12.1, 12.2. 12.1, 12.2, you're going to literally look at me and go, why didn't you teach us this in chapter 1? Okay. It's super easy. Okay. I'm going to stand back and let you do a lot of the math on the step 2. Okay, and then I'll come and play catch up. I want to see what you can do. I don't care if you use your calculator, but I want you to try to draw it as well. But on this one right here, a wedding website states that the average cost of a wedding is $29,205. One concerned bridezilla, because trust me, only a bridezilla will do this, hopes that the average is less than reported. To see if her hope is correct, she surveys 36 recently married couples and finds that the average cost of a wedding in the sample was $27,338. First off, where would you do that? She had to go on Reddit or something like that, or probably like TikTok. Start asking people. Okay, assuming that the population standard deviation is, what did they just tell you? Sigma is what? Known. They told you population is this. Okay. Is there sufficient evidence? And this is going to help you. Listen to this last part. If you're having trouble with knowing whether there's sufficient evidence or not sufficient evidence, read this last part. Is there sufficient evidence to support the bride's hope? Okay, at the 0.02 level of significance, that's your alpha. That's what you're looking for. Okay, is there enough evidence to support this? Okay, so first off, benevolent as I am, I'm not benevolent, that's Hawks. They give you the mean. Obviously, they both are gonna be means, and they're both gonna be the 29,700, 205. One is equal because it has to be. The null is always an equality statement, okay? But what is our alternative?
Less than,
Less than. She doesn't want to spend more money, she wants to spend what?
less than.
Less the money. That's my wife right there. She wouldn't be doing all this math, she'd be asking me. Be like, you, get out there, find out where there's less money. Yes, Mrs. Clark. I will do that for you, madam. Okay, so yes, it is going to be less. We put this in here, less, we got that, but it is important to know what? Left tail test, you're gonna need to know, okay? There's nowhere to put it, you just gotta know it. It's a left tail test. Look at where the alligator's butt's pointing. That helps you out a little bit. It's pointing to the left, so we're doing a left tail test. Good job. There, I'm gonna give you about 3 minutes. You're trying to find your test statistic, just like I did earlier. Yes, fine. Use your calculator, but work it both ways. Because remember, one way's for your final, that's great. One way's for your project paper. Okay, so you need to know how to do both. I don't believe I've uploaded notes yet for this. There's a reason. Some people are using my notes to just stare at them during class. So. They'll be loaded on Friday. While y'all are working, I was nervous about having to upload videos this weekend because we bought a house and there's no internet. Like there's no internet service out there at all. And so we went and bought that Starlink, which was actually pretty awesome. Okay, because you can take it off your roof and put it in your car. You can drive around anywhere you want. You got internet wherever you want to go. It's very weird. That's the fastest internet I've ever seen in my life. And, okay, I'll take that back. If you're a gamer, you would hate it. I'm not. I don't play games at all. Okay, but for what I do, man, it uploaded fast. So I was like, oh, sweet. Okay, I can still upload video. So there was a worry. I think I may have actually downloaded videos or notes for this one. I'm going to do it the drawing way first. Okay. Now, just to let you know, I am going to give you the formulas for all these z-scores, everything. You're going to get the formulas on video. And before we leave today, I'm going to show you what your review looks like because your review is a little deceptive. Okay, because it does show some things that will not be shown on your final that I don't want you to be thinking, why isn't that there? So, because I'm nice on the review, I'm mean on the test. Isn't that kind of how it's supposed to go? Okay, so look at it this way. We're going to be using the z-score. And our z-score is going to be x bar minus mu, all divided by the standard deviation and the square root of n. Well, that means we got to find out some information. We need our x bar, which is, what is it going to be? 27,338, correct? We also need a mean, which is going to be my 29,205. I need that standard deviation, which is 4,532. And I need a number of samples that my wife sent me for. She sent me and I found 36 people who lied on the internet. Okay. I know that I'm dealing with a left tail test. Okay, so I need to remember that. So since I'm dealing with a left tail test, I can go ahead and draw me this little bitty arbitrary little kind of drawing right here. I also know my level of significance is 0.02. Okay, now I'm going to just scroll back real fast because you might not have this one. 0.02 says what? Look at, we're using the same one, except we're doing a what? One tail test, two tail test. What are we doing? A what?
A one
A
cent.
one-tail test. Okay, so notice I can't be using that 2.33 I have circled. I'm going to be using that 2.05 now. We'll come back over here where I've been working and realize, is it gonna be 2.05? Negative 2.05 because it's a left-tailed test. So I know the z-score here is gonna be negative 2.05. Okay? Good so far. But now I can do the math, okay? So I come in here, start putting everything in, I get 27,338 minus 29,205, all divided by 4,532, take the square root of 36, which is just 6, okay? And realize that I get negative 2.47. Well, where would that sit? To the left of that number. So wouldn't it be, I mean, let's be honest, probably right about in there somewhere. Does it really matter? Do you need to be exacting exactly where it's at? No, you just know what? It's in the red. Okay, so this negative 2.47 says what? What are we doing? We're rejecting. It's in the rejection zone. So here on this side, we're saying we are going to reject the null. Your answer for this one would be, for step 2, would be that negative 2.47. That would be your test statistic. It's very hard to say it. Say test statistic like 5 times fast. See how well you can do it. Yeah, it gets really, yeah, immediately, yeah. Get really hard. Good news. You got a calculator. So for your final, come in here and you're going to be using the Z test, okay? So on this side, we're going to use all the same information from before, right? But then we need to make sure that very last button that we're going to be putting in there is going to be a left tail test. We got to make sure that we put it as a less than, right? And then you're going to get a Z value. Well, it should be the same. But then what's the important value? The P value. So what do they give you for a P value?
Or one.
0.0, 0 point what? 0.1. You get P is equal to 0.01. Okay? Which I know my level of significance is 0.02. Well, is that greater than or less than? Hmm? 0.01 is greater than or less than 0.02. There you go. What do you do when you're less than? Go back and look. When in doubt, when you're less than or equal to, you do what? Reject the null. Well, we already knew that, didn't we? Because of our drawing. Okay? They match. They better, because if we're rejecting on one and failing to one, we did something wrong somewhere. Okay? So yes, you're right. Here, we reject the null. Okay? Which means you got to go to step 3. And since we know we're rejecting the null, let's turn this once again into a coin flip. We're rejecting the null. We're not failing to reject, so we know this one doesn't count. And we know this one doesn't count. So let's just get it to 2 answers. That's a good test taking strategy. You're welcome. Okay, so we reject the null hypothesis and conclude there is sufficient evidence at the 0.02 level of significance to support the bride's hope that the mean cost of the wedding is less than $29,205, or is there insufficient evidence?
There's sufficient evidence
Insufficient?
because you're successful to reject the null hypothesis.
What do you think? Sufficient evidence. You have found enough evidence because you're rejecting the null. Okay, remember, when you're rejecting the null, you have found sufficient. So you're gonna come in here and put right there. Good. And there, ladies and gentlemen, is 10.2. Any questions on it? Murky anywhere?
Whenever looking at the P value, I kept on getting 0.91.
Check your numbers. Did you put in, look at your numbers. Walk me through it. Did you, for your mean, did you put 29,205? Standard deviation of 4,532. X bar of 27,338. Your N of 36. And then remember, you have to put the less than. And then you're gonna be looking at where P is equal to. Because it'll give you an X bar, right? And then it gives you what? A Z score, and then it gives you a P value, I think, because it depends on the calculator, but I'm thinking it goes in that order. You get it?
Shouldn't the X bar be 29,205?
It's gonna calculate something different. You don't need to worry about that X bar at all on it. The X bar, you mean on your calculation? X bar is 27,000. X bar is your sample mean. Okay? Good?
Yeah.
All right. Let's jump in. Let's start 10-3. We'll finish up 10-3 and 10-4 this week. Well, what do you think 10-3 is gonna be about? Let's be honest. Come on, go back to 8-1. Sigma was known. Now sigma is going to be what? Unknown. Hypothesis testing for population means sigma unknown. Okay? Good news. There's a calculator button. Bad news. Still got to draw it. Okay, if your problem requires you to draw it, remember you have two choices of which one you want to do. Okay, so be very careful about that. Once again, same thing, make sure all the conditions apply, make sure that you've taken enough samples. Are they above 30 or what? Population is probably normally distributed. But the difference with this one is they're going to be saying, hey, sigma is now unknown. That is literally the only difference, okay, here, in that you're still going to have to say, here is my null. Here's my alternative. Decide which test statistic you're going to use. Is sigma known? Is sigma unknown? We'll go along here a little bit later. We'll get into proportion. We'll get into variance. And then we draw a conclusion. Do the math. If we're drawing it, did it fall into the fail to reject or did it fall into the rejection region? We're still using the same alphas. Okay. Now you're going to be looking at the t-score because remember we're not using a z-score anymore because you don't have that anymore. You do not know that. So if a standard normal curve is defined by its mean and standard deviation, a student's t-distribution is defined by what? Think about it, go back in time. It's been a while. Start with a D. E, G, R, degrees of freedom. Remember, you have to look at the degrees of freedom. Okay. Well, what's degrees of freedom? N minus one. Don't do 1 minus n. You're gonna get a negative number. Okay. N minus 1. Okay. So whenever they give you the sample size, if you're drawing, that means you're going to have to go look up that little chart that's in your book, or you also have a calculator button called inverse T. Remember that one? You give it the area that you're looking for, and then you can put in the degrees of freedom. Remember, your degrees of freedom is not the number of the sample size, it's N minus 1, and that's what you would be putting into your calculator, okay? So this right here, once again, is important for your project, okay, your project paper. Okay, but if you're not going to be doing, still gonna need it. Good news is, once again, for your calculator use, I'm going to give it to you now. You will once again go to stat. You will once again go to test. And then now, instead of going to Z test, guess what you're gonna go to? Right beneath T test, okay? So we're gonna come here and go for your T test. So there's your calculator use. Once again, look at that carefully. Got left tail test, right tail test. Okay. And then if it's the absolute value of that, you're gonna get a two tail test. I'll show y'all one of those. You're not really gonna get one of those on your test. I'm gonna see if I can find you one to get, because that one's better explained by an example, okay? But I'm telling you right now, 2 years I've been trying to find one. Can't ever find it, okay? So maybe good news, okay? If for some reason Hawks ends up giving you one, send it to me, but I can't ever find it, something, okay? So, but they may have done an update. Hawks is always updating their stuff, okay? But let's look at this one. Okay, same thing as before, and then once again, we're gonna have to draw some, if you're gonna do the p-values, it's the same thing. Once again, if p is less than or equal to alpha, then we reject the null. If it's greater than alpha, we fail to reject. Okay, same thing as before. Okay, one way is for drawing, one way is for calculator, one way is for project paper, one way is for the final. Okay. Rigorous on the paper, you got more time. Calculator work, because time is like gold on the final. Okay. Nurses. We'll do this one very carefully. I'm going to draw it out and then we'll finish up for the day. Nurses in a large teaching hospital have complained for many years that they're overworked and understaffed. The consensus among the nursing staff is that the mean number of patients per nurse is 8.0. The hospital administrators claim that the mean is lower than 8.0. To prove their point to the nursing staff, the administrators gather information from a simple random sample of 19 nurses' shifts. The sample mean is 7.5 patients per nurse with a standard deviation of 1.1 patients per nurse. Test the administrator's claim using an alpha of 0.025 and assume the number of patients per nurse is a normal distribution. First off, why are they telling me it's normally distributed? Why does that matter?
That way, when we do the drawing, it'll be symmetrical.
No, close. You're close. Look at my number of samples.
It's less than whatever.
It's less than 30. Central limit theorem says this. For central limit theorem to work, you got to take a sufficient number of samples or things have to be normally distributed. So it's telling you, hey, since we have less than 30, I'm letting you know it's normally distributed. Okay, so the conditions are met. We can go on. Okay. Well, now you have to say to yourself, obviously, yes, I get your go. Well, sigma's not known. Yeah, but how would you know on your final right now? Because I'm not going to tell you whether you're in 10.3 or 10.2 or 10.1. How are you going to know that you're in 10.3 on your final? Well, do you see the word specifically population standard deviation? No, that should be a telltale sign. That shouldn't be all you go on. Don't hang your hat on that. But you should go, okay, hold on. Notice the line. The sample mean, they're trying to work, they're trying to have sense with sample. The sample mean is 7.5 patients per nurse with a standard deviation of 1.1. Notice they lump sample in with that whole sentence. So they're saying that's a sample standard deviation there. Okay, that's not a population. Okay, so you gotta be careful. So now, we're gonna come in here and we need to know our null. And we need to know our alternative. Always, because if you don't know that, you don't know if you're dealing with a left-tailed, right-tailed, or two-tailed. Okay? Well, the mean, we know we're dealing with mean, so I'll put that in both. I know the top is always going to be equal. I do not know the bottom yet. But the mean is equal to what? Huh? Exactly, 8.0. So I can always put this down, 8.0 there as well. But now what? Less than, notice to prove their point, right here, the hospital claim that the mean is lower, right there. So we're gonna be doing less than, which tells us what kind of test we're using. Left tail test. All right, well, the left tail test says this. I'm gonna come over here and go ahead and just draw out this right here. That means I'm gonna be dealing with something right here. But this real thing right there, that is not a Z-score anymore, is it? Yes, that is going to be your T-score. Good news, they gave you the value for that, okay? So we can come in here and find that. Okay, remember if we're gonna have it. There it is right there. So we come here, we're gonna find that T-score. That's gonna be the test statistic you're gonna need anyway, okay? Come in here, you're gonna have X bar minus the mu, all divided by, notice the change of notation here. Not a sigma, but S. Because it's a sample standard deviation. Other than that, everything else stays the same. If I come in here, then I've got the square root of N. X bar, U, S, and N. I know I'm gonna need all those. Well, let's come in here. We have an N of 19. We have an S of 1.1. What is my mean? 8.0, right? But then they give me a sample mean of 7.5. (7.5) minus 8.0. Fill in the bottom, 1.1 divided by the square root of 19. When you finish the math, I'll go and give it to you. Finish it, make sure you get the same number as me. I get negative 1.984. Well, that's just my test statistic, isn't it? Well, that just tells me where I'm at. But here's the problem. I don't know what that T-score is, but that's fine because I know the area under that part right there is what? 0.025. I also know this, that I can come in here and do my inverse T. Remember that? You can put that into your calculator. And when you do, you get this number right here, negative 2.101. Well, what do you think? Are we gonna fail to reject? Where would be by test statistic? Wouldn't we all agree that it's gonna be right? Roughly around there, right? We're not gonna be exact, but can we say that this would be my negative 1.984? So would I reject or would I fail to reject?
Fail to reject.
Fail to reject because where it's at.
Outside.
It's outside that little colored in region. It is not in the rejection region.
Which one of those would be the critical value?
Critical value, okay, your, not critical value, remember, you're looking for your alpha. This is your guy here. Your test statistic you need is this guy right here, okay? The critical value that you're looking for would be this guy right there, okay? That's the critical, that's the one that says, hey, this is where you got it, this is where you're looking, right here, right? Good so far on that one? Let's stop there, we'll come back next class and we will work that on our calculator, and we'll continue on with 10.3. And then start 10.4.